At this point in the exercise, you should notice that things are not going very well. And if we take a look at the CPU, we're going to see that the dominant consumer is in user space, which means that we're going to want to look at the GC log. So what I've done here is I've loaded the GC log up in Sensum, and we can just reload since it's been running for a little while here, just to get a fresh view of what's going on. And if we look at heap usage after the collection, we're going to see, okay, so it's gone up and it's leveled out, and there's max heap. And so as we're looking at this, we can see that, okay, we've just completely filled memory. If we look at tenured, yeah, tenured is now completely full. We're pretty well assured that we have a memory leak here. So now we have to go through the diagnostic process to try to sort out root cause of this particular memory leak. So let's start by just, I guess the easiest way to do this is just turn things off. We're just going to turn off everything. So I'll bring up the window here where I open the application server in. It's still running quite hot, so we can just finish it up just in the interest of time here. Okay, so now I can do an app server restart, and I'm going to do a JMeter restart. Great, so there's JMeter restarted. In this case, what I'm going to do is I'm going to just back off on the load considerably. Now we can do this with a memory leak because this is a flaw in the application's code that's essentially managing the life cycle of the application. So in this case, I'm just going to drastically reduce the load here to 75% of what it originally was. Next, let's just start Visual VM here. And we're going to take Visual VM and attach it to our application server. We're going to look at the profiler, go to memory settings, and we want to profile just about everything we need to profile. So there we go. We have primitive arrays and all classes, everything on a separate line, just as you saw mentioned in the pop-up. Memory profiling turned on. Sort by generational count. And now, just going to go back to JMeter, and we're just going to start the load. So I'll get rid of that screen for the moment, and we can just follow the generational count as just sit and watch as things develop. You can look over here and monitor things, and you can see that heap occupancy is rising. We still have some headroom because we slowed things down, but before we run out of headroom, which makes it very difficult to work with the tools, let's just go and shut this down. So I'm just going to stop this test here. Hopefully that won't take too long. If it does, which it is, then we're just going to go boom. Bring that one up again. No. Okay, so that's gone. Okay, so let's go back to our profiler view. And let's see. Let's just take a snapshot because this is going to be bouncing around for a while, and that'll just be annoying to read. So I'm just going to take a snapshot here. We come back to the monitoring, and the other thing we want to get is a heap dump. So let's capture all this data right now. Okay, so that should be loading the heap dump. Okay, so let's go find our classes here. And if we go down, whoops, let's sort on generational count again. That'll make it easier. There's our tip, document, and tip. Okay, so let's open up tip first. And you can see there's two sources of tips here, and one of them is really inconsequential, but this is the big kid on the block here, so this is one we're going to pick on. And if we start at the bottom, you can see that we have here, what is that? That's servlet, application servlet, seems to be passing on to application servlet, into domain object, tipped documents. This is looking good. Tip documents, get tip document, loading them, loading a tip document, and there's our constructor for the tip. So we get an idea of what's going on here. So really tips document is going to be key, as well as these particular servlets. There's things that we're probably going to look at later. Again, if we look at tip document, not really much of a surprise here. You can see it's pretty much the same execution path, not quite the depth, because you could probably guess that a tip document consists of tips. So I would create a tip document and then create all of the tips that belong to that particular document. Okay, so that's cool. So that's our execution path that we want to follow to figure out if we can get a better handle on, who's messing up on the life cycle aspect of things. Let's take a look at here. So this is going to be our heap dump. So we go into our objects view, and when we go into our objects view again, okay, so there's our tip. So let's pick on it. So I can open that up, and you can see, okay, there's every single instance of tip in heap, quite a few of them. Lots of tips here. So I can just like randomly grab one and open it. And when I do, I can see the structure of the tip, and basically the structure is going to be this line as a field, and there's a static field which is a class loader, but that's just an artifact of the runtime, so I pretty much can ignore that. But and we can open up the line. You can see here's the structure of a string, so should be no surprises in here per se. And then I can come back here, and there's a couple of different ways I can do this. I could just execute this can query that basically says, show me the nearest GC route, and it's going to compute this for us. And it might take a little bit of a while. There's a progress bar down in the corner here, and the progress bar is indicating that we're 30% through this query, so we'll just let it finish. Okay, the query is finished, and you can see that tips document is a Java frame, so that makes it a GC root, and it has element data in array list, and in the 128 slot in that array, where is it? Yeah, this array of object, we're going to have a tip document, and we're going to put tips in the element data in this array list. And essentially what you're seeing is here we have a collection of a collection, right? And so we have tips documents containing tips document, which contains tips, and all these things seem to be backed up by collections. Now if we go through this view here, we're actually going to see artifacts of the profiling that unfortunately we're going to want to try to ignore. So if we just focus on, so that's a profiler artifact. So if we just ignore that, then what you can see is that we're basically walking down the same path. Going pretty much in the same direction. The only interesting piece of information here is that in this case, well, actually, in the GC review, in the other view, what we saw was this all keywords field in this class keyword. Cool. So that's probably something else that we might want to look at, or it's somehow involved in this leak. So we can take a look at that when we finally go to the source code, which I guess should be now. So let's fire up IntelliJ. And while I'm doing that, just to help the tooling out here, what I'm going to do is I'm just going to go back and suspend that. Now the ID is, so the profiler is going to complain. We can help that out by basically going back to the profiler and say, okay, don't bother profiling anymore. We don't need any more information from that. And then we can just say kill. Not really supposed to kill this way, but sometimes it's difficult to kill a JVM that's been beaten up. Okay, so that's all done. And so IntelliJ has started up over here. So let's just make it visible to you as such. And so let's recall some of the things that we wanted to look at. So the execution path took us through simple query. And in the simple query, there's our do get. And in the do get, we're actually doing some work with the URI for some reason. That's probably not a good idea, but you know, that's what we're doing anyways. And it's doing some calculation here. If it starts with tips, else we're going to look for something else. So I don't think we're actually in any of these cases for whatever reason. So I think what we're actually doing is we're going to execute this thing here called do valid query. So if you remember from the profile, which we can take a look at here, go back to snapshot. Yeah, so it was going from the do get to the do valid query. So this is a path we're going down. So let's go figure out where it is and going to run to. And it should actually go through wildcard query. And okay, there's a do valid query. Oh, and look at that. There, lo and behold, there's a tips documents right here. So we have a new tips document being created. And then we iterate, I guess, over all of the tips document objects in the tips documents. That's how I'd guess we'd do it. Yeah, and so that seems to be it here. And oh, and here's the get tips document. So if we go back to our profile again, here's the iterator, get tips documents. So we're we're just following the stack trace right up. The get tips documents is saying like, oh, okay, this is interesting. So it's saying if the tips document is null. So what's that? That's this array list of tips document. So if we don't have any documents loaded, then load them. And this is saying load them from this place. And then we're actually going to do the load. And so we got a buffered reader, very good. And we're going to do some parsing, and we're going to create a new tip document here. And it looks like in here, basically what we do is we add in new tip. Awesome. So we go all the way up. So where are we? We are here. No, here, right? Tip document init for this one. And so we're here at the init. And this looks like there's something going on inside the init. So let's just go straight up, all the way up. And oh, look at that. We have keyword, extract keywords from the incoming string. And the extract keywords seems to be doing some other stuff. But remember the all keywords list that we ran into? So let's just go back over here, and you can see that at the top. Yeah, here we are, all keywords. So yeah, so we're finding all, so we're basically adding all these things into these all keywords. What is all keywords? Well, it is there we are, all keywords. It is a static concurrent hash map. Right, and that just smells like trouble right there. Generally, collections are going to be involved in a leak, and static just makes you a lot less comfortable with things, or at least it does me. Because that, and it's public, which is, yeah, now you've got no control over your world. So, just any bad thing can happen at this point. Okay. So we've walked the stack all the way up. We found that this file is being loaded if the conditions are correct. And so if we go back to the wildcard query, we're going to see that, okay, so what needs to be done here? So on the iterator, let's go back over here, up. It's saying, okay, so if the tips document is null, but notice this. That leaves one with the question, when is tips document ever not going to be null? Because we have a new local variable here, and it gets instantiated on every single call to the servlet, which means that that file is going to be loaded on every single call to the servlet. And then that's going to accumulate into that very ugly static concurrent hash map. So probably you might want to rework the logic in this in some cases. In other cases, let's just get rid of the problem right at the source and basically say, okay, let's not create a new one of those every single time. So let's just do this right at the beginning. And one other thing that we probably want to do is we want to say in the initialization, so we're going to say documents.get tips documents. Oh, and of course it wants to do something with exceptions. So let's add some exception handling around it over here. And we're just going to log the e.getMessage. If that's in case there's something bad happening when we actually load the document. Okay. Awesome. So let's now go and just make sure all of this is saved. We don't need the IDE anymore, so we can basically drop that. This information we don't need. If you did want to keep some of this information, you can just come over here and you can take these these snapshots in the heap dump, and you can just save them and reload them later. But I think we're pretty much done with those, so we can just eliminate them. Might regret that. Sometimes I do delete it, but often you just want to save this data just in case you need to go back and sort out what's going on with it. Okay, cool. So now let's compile. And let's run our application server again. Okay, so it looks like we've taken down JMeter the hard way. So let's bring it back up. Let's get some proper CPU, or a little bit better CPU monitoring up here at the same time. And what I'm going to do is I'm just going to clear the CPU history so we got a clean view of it. We're going to look at that. Okay, so we're going to bring JMeter over again. And I think we're pretty much just ready to go. So let's just run it. And there we are, running. Let's bring up Sensum. If I was really baselining, I wouldn't want all of this stuff running, but right now we're just looking to make sure that we got rid of the memory leak. Okay, so Sensum is up. Let's just take a look at the GC log. And voila. We have a flat line here. indicating that heap is a lot more stable. To summarize what we've done here is we first confirmed there was a memory leak, and then once we confirmed there was a memory leak, then what I did was set up Visual VM and configured Visual VM to profile the application, to memory profile the application, and to collect the generational count. Once we identified the leaking object using the generational count, the tips, and the tips document, what we did was we characterized the life cycle of that particular object. We found the bug in the lifecycle management, and we corrected the bug. And once we had corrected the bug, then what we did was rerun the application again. And in the process of running the application again, we noted that the memory leak was gone. And in my case here, looking at the CPU chart, we saw that the system time was running high, but that was simply because I'm running screencasting software here. So the screencasting software is actually responsible for the high system time. So in order to get a proper diagnosis for the next follow-on problem, I'd have to do the screen capture differently or not screen capture it in order to get it to work properly.